Hi guys, this is Jesse. Welcome to this new Dual Universe Pre-Alpha gameplay tutorial. This time we're going to talk about interactive elements, links, and how you can use that to make interactive setup in your construct that could go actually as far as creating puzzle games within Dual Universe. So it's a very exciting feature. We didn't talk much about it, so let's have a look at what we have in store in detail. I'm going to enter build mode into this setup demo construct, and let's start with the basics, deploying a door just here, interacting with this door. So it's very simple. I just go to the door, press F, and that's it. So I can open and close the door. This is really the basics, and that is true for many other elements. You can just interact with them pressing F, provided that you have the proper rights to do so, but this is part of another tutorial. So now let's get something a bit more interesting. I'm gonna add here a little bit of voxels next to the door, like that, and let's add a button so I can actually control this door with a button. So I'm gonna take a switch that I'm going to put over here, and I can use the linker tool, which is currently number 5, to connect that button to the door. Just click on the button, click on the door, and that's it. You have a link that you see here appearing in blue. That is connecting the door and the button. So now if I press the button, that is if I activate the button, it will actually propagate a signal to the door, and so the door can be opened. So let's have a look more closely at how this link is actually structured. If I recast the link, it becomes white, and you can see that some informations are displayed on both sides of the link. You have the name of the element, the first element on the left, switch 3. 3 is just an internal number to designate that element, and on the right you see ship door, and you see that I've connected the out plug from the switch to the in plug of the ship door. So more about this in a moment. So first thing I'm going to do is that I'm going to rename this switch so that it is more interesting than switch number 3. Let's call it main entrance button, for example. And I can also rename the door, rename elements. So this is true for any element that can be named. Let's say we call it main door. So that's better. So you see that when you recast the link now, you're going to be shown the name of the proper elements on both sides of the link. So as I said, you also see out and in, which are the names of the plugs that are to which this particular link are connected. So it happens that a switch has only one plug, which is an out plug, and the door has only one plug, which is an in plug, and they both are of the type signal. So that's why you can connect the button to the door, because you have an out plug that matches the type of the in plug of the corresponding element. But actually, some elements are displaying much more complicated situations where you have all sorts of different out plugs, sometimes also in plugs at the same time, and you have different types of links. So this is a signal type of link, so it propagates signals. Think of it as a sort of electric information. But I'm going to actually deploy some other elements to show you that there are other types of link. This is a container, and I'm going to deploy here an engine. So just for the sake of it, I'm going to connect them. And here you see you have a different type of link. You have what we call a fuel link that connects the container and the engine. If I'm actually deploying now, for example, a container with a dispenser. So let me get a dispenser. Here we go. And if I link those two guys, we have another type of link here, which is an item type of link. So the dispenser will get its item from the container, and this link here is actually transporting items from one side to the other. And here you're transporting fuel from one side to the other. And here you're transporting signal from one side to the other. So you can look at the color of the different links so that you can have an idea of what they are in terms of type. Most of the things we're going to talk about here is only focused on the signal link, because this is where you are going to be able to make really interactive, composable setup with the link system. So let's have a look at what we have in store beyond the button and the door. So the first thing I want to introduce is that there's a difference between a switch and a button. So this is a switch. It actually has a state. It's either on or off. But you also have buttons. So let's use this. with deploying a button here. We can connect it, for example, to a light. This is going to be a good example. So let me turn this light off, and I'm going to connect the button to the light. So once this is done, going out of build mode, you see that if I press the button, the light goes on, but it stays on as long as I press the F key. If I leave F, then the signal is out, which is very different from what happens with switch. So switch as a state, and a button is just active as long as you press it. That's one very useful difference depending on what kind of interaction you want to trigger. Let's have a look now at another element which is extremely useful, which is the relay. To start with, I'm going to show you first how to remove a link. It's very easy. You just recast the link and you press Alt and click. That takes the link out. So it's a very simple way to disconnect two elements. Say, for example, now that I would like to control both the door and the light here at the same time pressing this button. So I can do so using the relay, which is an element available in my inventory. Here we go. I can just drag and drop it here, let's say on the door. And now I will put the relay here and rewire this, taking the link out, rewiring the button to the relay and the relay to the door and the relay to the light as well. So if I press now the button, both things are activated at the same time. So it's interesting to notice that the links are also oriented. You can see these arrows here propagating. Sometimes you may have situations where you can link an element from, for example, this light to this relay or the relay to the light. It's not the case here, but there are some elements that could be plugged in both ways with different meaning. So in that case, the particular order by which you're going to click on the first and then on the second element is important to actually tell the system in what directions you want the link to be connected. So let's go to the next element, which is the pressure plate. Very useful. So I'm going to disconnect the door from the relay, and I'm going to make it so that when I step next to the door, it opens. To do this, I will use pressure plate. So I just select pressure plate here, and here we go. I can deploy it just in front of the door, connected to the door, and voila, when I step on the pressure plate, the doors open. So this is a very simple mechanism as well, an alternative to the button. It depends on the situation, what you want to do. And of course, you could use the pressure plate with any other thing, like the light or any particular setup you want to create. It works for anything. It's just a button, basically, that you trigger by walking on it. Let's have a look at the next element I want to show you, which is really cool. It's called a force field. So let me just pick a force field. I'm going to go in my inventory. It comes in with different sizes. Let's say, for example, I'm going to try this 2 meters force field. And I'm going to rotate it and position it, let's say, over here. So that's it, it's positioned, and when I activate it, it creates a force field that will hit the first voxel that it finds on its way. There's a maximum length, after which it will stop. So, but it will actually adapt to the shape of your environment, and as the name implies, it's a force field, so I cannot go through it. Very useful to create simple kind of doors. But also this force field can be used horizontally. So let's say, for example, I'm going to deploy one here. Let's say I'm going to take a larger one for the sake of it. So here, and I'm going to deploy the force field, activate it, going out of build mode, and now I can just simply walk on it. So this is effectively a bridge that you can control with signals. So you could have a button, you could have a pressure plate, you could have all sorts of things that will actually make it work as a way to connect different parts of your construct. So here we go. The other thing that is very nice to couple together with this kind of elements is a presence detector. So here again, let's have a look. You have a lot of those in the inventory. They come in different sizes in terms of area. So let's say, for example, I take a 4 meter detection zone. I will put it here. And I'm going to, so you have a visual feedback that tells you where the zone is actually active, where it spans. So I'm going to deploy it here. Let's say if I activate it, I make it actually visible, so I can see the zone by pressing F, or I can hide it if I want. and let's connect it to, I don't know, let's say some lights. Oh, this light is better. And I'm going to connect the detector to the light here. And now if I actually step inside the zone, the light is on. If I step out, the light is out. So it's extremely interesting because it allows you to actually trigger some events when somebody's getting near something in your construct. By actually setting the zone to invisible, pressing F, you can actually make it like a trap detector. I mean, a trap trigger that will do something whenever somebody is getting in certain areas. So very interesting to create interactive setup. Could actually be coupled to a door, by the way, so that when you get close to the door, it opens it, and so on and so forth. You can do anything you want combining these things together. So let me show you another interactive element which is really cool. It's the laser detector. So to do a laser detector, you need a laser emitter. So let me just drag and drop this guy here and the detector here. And you will put the laser emitter on, for example, on one side like here, activate it. So the laser goes on the other side. And you will put a detector just in front on the other side. So now if I connect the light to this detector using the link tool, then whenever actually I cross the laser, the light goes off. So this is very interesting to make detectors, traps again, and all sorts of interactive setup with the laser that can be connected to anything. This is just a light, but it could be anything that accepts signal in. But suppose now that you would like to actually do something different, that is, it's not when I cross the laser that the light goes off, but the opposite. So basically, when I cross, the light goes actually on and it's off by default. What you want to do is to invert the signal. So that can be done with operators in particular. So I'm going to get in with the deploy element tool. There is a not operator, which is basically inverting the signal. So when there is no signal, it creates a signal, and when there's a signal, it does nothing. So if we rewire now the links here so that the detector goes into the not operator and the not to the light, then we have the expected behavior that the light is off when I'm not into the laser, and when it goes into the laser, it becomes on. So this not operator is actually one among several other operators that you can use to do basically logic, Boolean logics on the signal themselves. So let's have a look at what other operators are available. There are actually two main operators that we've implemented so far. So let's have a look at them. The first is the AND operator, which I'm going to deploy here. That is capable of combining two entries that must both be active so that it propagates to the out plug. So let's do the wiring. So with two switches connected to the AND operator, and let's figure out if that works. So I'm going to connect the out plug of the AND operator to the light, and I'm going to plug in the two switches. So if now I press the first switch, nothing happens. If I press the second switch, then both are active, and then the light switches on. If any one of those guys turns off, then the light is off. So this is basically what is an AND operator. Interestingly, this is the first operator that actually has several plugs in entry versus just one. So you might actually want to select which plug you're going to plug your particular switches in. So let's have a look at how this is done. So if I select this particular switch, then I could just click on the operator, and it will find a free available plug so that it connects it to it. But if I want, I can just right click here and select explicitly which plug I want to plug my switch in. So in that case, it doesn't really matter because the AND operator is what we say is symmetrical, so it doesn't really care whether you put it into A or B. It will be exactly the same. But there are some cases where we're going to see later, where you might actually want to effectively select which in or which out plug you are going to use when you do your wiring. So this is something we will get back to in a moment. The other operator I want to show you is the OR operator. So let's have a look. The OR operator is going to work a bit like the AND operator, but instead of requiring that every single one of its input is on, it will work as soon as one of them at least is on. So let's do again this simple example, I'm going to have actually manual switch. Let's put a button for a change and another button here. So we're gonna have three different switches and buttons here, and let's do the wiring, connecting this guy here, and this guy here. Again, here I could actually select the particular plug-in I want for any one of those guys, but it doesn't matter because the OR operator is also symmetrical. So here we go. So now what happens if I actually activate the switch? The light goes on. If I press any button, still on, and it works. Turn the switch off, press another button, I leave the F key pressed, it's on, press left, so it works as expected. As soon as any one of those guys is on, then it will propagate. So that's the OR gate. So let's have a look at another particular element you can use in a configuration like this, which is the delay line. So I'm going to pick it over there, delay line. This element is simply delaying any signal it receives and then propagates it later with a time differential of 3 seconds. So let's say I'm going to do the rewiring here so that the output of the out operator goes into the delay line. And what happens now is that if I turn off the out, the light will go off but with a delay. If I turn on this button, the light will turn on but with a delay, and then off again. So it's just propagating the signal as you would expect, but with a delay. So that this is very useful, for example, if you want to open a door when somebody is entering a certain area, but you don't want to close it immediately, so you want to give the opportunity for the person to actually cross the door before you close it. This kind of use is for delay line, and I'm sure you guys will find some other uses for that, but that's a fundamental part of the propagation of signals, that you can control time shifts in them. Now let's have a look at another set of very cool elements that you can use. I'm thinking about something called the counter. So the counter comes actually in different versions. The counter to 2, 3, 5, 7, and 10. And let's say, for example, I'm going to use the counter to 3, and I'm going to plug 3 lights just after it, like that. Let me turn them off to start with. And I'm going to plug a button to this counter. So doing the wiring, button in the counter, and counter to light 1, 2, and 3. So what happens when I press the button is that the counter is actually switching the signal out alternatively between the different out plugs it has. So it's effectively counting. So very useful to propagate things that will actually count how many times they have been activated. And this is actually a good example also of an element where you might want to choose what particular out plug you're using when you do a wiring. So let's see how we can do that. So I'm going to disconnect these guys, and here I'm going to right click on the counter before simply clicking on it when the link tool is activated, and you see there's this menu that allows me to select which out plug I'm going to use to start the connection. Say I'm going to use the second one, so now it's ready, and I can then click on whatever element I want to connect. So if you look at the link, hover over it, you see that on the left it's the out signal 2 that is used, so effectively the one I picked. So you can actually be very precise in how you want to wire those things. So I guess now if I count, you will see a different order. Yeah, it's going into a different setup because the order of the out plugs have been swapped because of my selection. So this is a very useful element. As I said, it comes into different variants. You can have variants with 2, 3, 5, 7, and 10 out plugs. So depending on what you want to do, you might choose one or the other. And finally, let me show you another very interesting element that is available in pre-alpha, but we need to still work on it to optimize it, but still I'm going to show you how it works. It's called the pulsar. The pulsar is an element that does pulsing, so it's like as if you have an automatic system that presses the button for you. So if I replace the button by the pulsar here, you will start to see that my counter is counting automatically. So let's redo the wiring. I'm going to take this link out and now connect the pulsar to this guy, and you see that they are counting. The counter is making progress automatically because the pulsar is sending signal for you. So this is one part of the interactive elements that you can use at the moment. We're gonna add more of them, but I think they're already enough to start to think and imagine quite amazing interactive setups. I'm thinking about probably things like puzzle games, co-op puzzle games, where you need a friend to step on a pressure plate so that the door opens and the laser can go through, so that it activates a force field that you can then use as a bridge to go to some other parts of the puzzle. These kind of things. So I don't know what you guys are going to make with that, but I'm really impatient to see what comes out of it. And tell us what is missing, maybe what type of elements you would need. We have our own ideas, but there are still a lot of things that we have not thought about that you can actually suggest. Thanks for watching. I hope you liked it, and see you in the next tutorial.